Okay, so let's talk on Google Kubernetes Engine, GKE. You can say GCP provide you can manage your application deployment in the cluster. So, what do you mean by cluster? Till now, whatever we learns how we can create server on the top of virtual machine, you can create virtual machine. Different way we can create the virtual machines from the console, from the CLI command, and even we can learn create from template. Even we can learn you can create the manage instance group means ki bunch of or clusters of VMs or servers. In the same context now, GKE also provide you can deploy your application on the clusters of nodes or clusters of servers, and the managing of the servers clusters are taken care by Google Cloud Platform itself. So if we talk basics about okay, so GKE, Google Cloud Engine, is a managed container orchestration service that allow you to run and manage containerized applications in the Google Cloud Platform. So GKE is the managed container orchestration service. Okay, what this service offer? Say, hey, you run and manage containerized application. So what do we containerize applications? Generally, whenever you are developing your applications, application developing, okay, your application development done. So generally, what you do, you come build them, package them, make jar file, and deploy on the server. Okay, generally. So every let's give we are deploying another different service. This you have to copy this package in a different server, copy this package in a different server, and you can deploy application. So containerized application is the one of a simplest way. You can just make one your container. Container just contain your whatever the deployment application package jar file, and what are the dependency, what are the everything. So these containers you can uh, run, or you can get from the public repository. You can store the your maybe Docker container registry. Maybe Google also have a container registry where you can just image these containers, and in this container, anyone can download this container and start running on a particular node. So now, yeah, maybe this is the publicly available you want, and or you can manually just restricted access. So nowadays, almost major application we are developing on the basis of containerized application. Okay, so we'll talk what the meaning of containers, right? Okay, so GKE is the based on Kubernetes. Okay, so what this service Google Kubernetes engine is based on the Kubernetes. And what is Kubernetes? Kubernetes is an open source orchestration system that automate the deployment, scaling, and management of your containerized applications. So Kubernetes is open source container orchestration systems are available, and this is the purpose of this Kubernetes: the make your application deployment, scaling, and management. All the things are managed by your Kubernetes itself. So you can say Google Kubernetes engines, or this Kubernetes engine is a public, and maybe you are talk about the AWS. AWS also offer you can deploy your containerized application with the help of Kubernetes. If your applications are using the Kubernetes, that is the good. You can directly ship from your on-premises application to the Google Cloud. Okay, so let's talk a little bit about the Kubernetes and what we understand about the Kubernetes. Same thing is the GKE. Just Google Cloud provide complete Kubernetes as a self-managed service. So whatever the manually you are going to manage your application under the Kubernetes, now all the management parts are taken care by your Google Cloud itself. Okay. So let's talk a little bit about what is the Kubernetes. So Kubernetes are sometimes say K8s is an open source or container orchestration system that's automate the deployment, scaling, and management of the containerized application. And now Kubernetes also is originally designed by the Google itself, and now this Kubernetes managed by the cloud native computing foundations that maintain lots of open source projects that are help us to build the cloud native applications. So this is the one of the core, you can say, project under the cloud native computing foundation. You can just visit this cloud native foundation website, and you can find a huge list of your open source software available for building the cloud native applications from the different perspective: the database, server, cluster, configurations, everything. So CNF Cloud Native Computing Functions. And if you want to learn more about the cloud natives open source software, please visit this. And one of the very good, or you can say popular open source software is the Kubernetes. And nowadays you can mostly, if any enterprise application or bigger size of applications, generally we are building that's required a highly scalable, and in those scenarios Kubernetes help us to manage. Let's talk about the container. But Kubernetes main concept on which they are running on the top of the containers. The containers is the actual your software, you can say, not software but the bundle of software plus library and runtime environment where these are going to run. Okay, so notice the containers is a lightweight and portable way to package an application and its dependency, such as a library setting, into a single executable package. So you can say whatever the enterprise application available. So what application required, what module requires, what dependency required, what are the setting requires, what are the everything. You can just make one container that contain your application, library, setting, and all other the environment which you require. This is known as a container. So this container just ready to run. So if this container is just a package of your executable software, and the containers share the same kernel as the host operating systems and run as a process on the host, but they have their own isolation environment, including the file system, network stack. There is very, very key concept here. Whenever now your package is ready, container package ready. So for running, you require the operating systems. So this is your operating system. In this operating system, notice the lots of resources, memory, everything. So one operating systems, yeah, you can say in the Kubernetes knowledge pod, can run multiple containers. In this operating system, you can run container 1, maybe container 2, multiple container you can run. The container contain itself application, required setting, library, everything. But container is a very lightweight. That means they can share the host operate. This is not required whatever the operating system they have, and the same operating system it's running, and they are sharing the uh, all the hardware resources. But be careful. Let's see another container deploy. So both container are run isolation, means this container does not know anything about the another container. So this is the beauty. Like if your application running look like they have an independent operating system, a virtual machine running, isolated environment. Even there is a not share your look like they have an individual file system, network system, stacks, over everything. So nowadays, this container is very lightweight. That means can one node or pod, you can run multiple containers, and each container run in isolated manner. Even they can share the networks or OS related information. Okay, so think of container as a virtual machine, simple, and but instead of running a separate operating system, it run on the top of host operating system and sharing the resources. This is the beauty. You can run your application on particular machines, and this machine, you on this machine multiple container you can run, and each containers or each your application look like run isolated independently. Okay, so if you talk the key feature of Kubernetes, so as we discuss, one of the key feature is your container orchestration. Means Kubernetes manage the life cycle of container, including deployment, scaling, termination, everything. So everything managed by your container. Whatever the container application, you don't just whatever how deployment happen, how scale up and down happen, and when the application is going to terminate, everything is taken care by your container orchestrations features. And one of the good things, this is a declarative configuration, means how you can define your deployment, services, pod, scaling, manage everything. You can say user define the desired state of an application using the configuration file, and Kubernetes ensure that key actual machine states are desirable, whatever state defined in the configuration file. Generally, they follow the YAML file. In YAML file, .yaml file, you can put, hey, this is my service, this is my deployment, this is my replica set, this is everything. And everything now take care by your Kubernetes engine, hey, I will manage this. And one of the also key feature about the self-healing. The Kubernetes detects and restart containers that fail or some problems, some network issues. So this is the responsibility of Kubernetes itself. Whatever in your particular cluster, the number of ports are running, number of servers running, and if they are managing, they are monitoring every your containers, and if they found any, they detect anything problem, they can automatically restart your container, something failing, maybe you need your application need a high load, you want to scale, they are adding more and more container. So auto healing, self healing, you can say, Kubernetes offer. That means you don't worry. Your problem, failure, something happen, they automatically restart. If required more containers, they add more containers. And if you talk, also they are offering the resource management. That means they provide efficient use of a resources to the CPU memory. Because nowadays your operating systems on the same operating system, multiple container can run by the Kubernetes, and multiple application run that are in isolation, but still they can share your CPU memory, so that our containers are can be run efficiently. So you can say whatever the resources we have, Kubernetes help us so that we our applications, our resources are properly utilized. And as I discussed, they support the scalability because Kubernetes allow to scale their application horizontally and over vertically. So they're both kind of scaling support. Let's if your applications have a clusters of multiple application. If your application uh, request high, so you have to configure, hey, whatever the machines, you can make a bigger machines, add more CPU, add more memory to handle the request. Yes, if you want, they can configure. I want to vertical scaling. Vertical scaling means the particular server I want to make a more space, more memory, more CPU, so that they can process high number of requests. If still after the full capacity, because every hardware have a limited number of expansion of the CPU or memory or RAM, so still our application required more kind of a server. They can add another more server, add more server, add more server. This is known as a horizontal scaling. So Kubernetes support both. You can just configure, hey, I want to here horizontally scale if the number of requests or number of user traffic is going to increase on my server. And automatically, if you want to decrease, you can also configure. Okay, so by default, they support the scalability, means your application can scale as per your user traffic required. And good options, this Kubernetes options is support the multi-cloud support. That means Kubernetes engine can provide the various cloud providers. As we talk about, the GCP provide, Amazon provide, Azure provide an on-premises environment. That means if you are building application on the concept of Kubernetes, and now your application is very flexible, you can say, that can be deployed on the different clouds, GCP, AWS. So these are the basics, key features. Lots of features of the Kubernetes, but surely these are the key features we have to memorize, like scaling and resource management, container orchestration, and all, like self-healing and declarative configuration. So, what are the overall, what are the architectures of these Kubernetes? So, these are the high-level architectures. So, multiple things here you can notice, like a cluster. So, cluster is just like a group of, you can say, machine or virtual machine or any kind of operating system. Okay. So, notice there is a one machine, one server, you can say, another server, and another server. Okay, so these all group considered a cluster. Cluster means your set of nodes. Sometime you can say this is the node 1, node 2, node 3, similarly. Okay, node means virtual machine, you can say, or server, you can say, or operating system, you can say, right? So here cluster means, always a cluster means the combinations of set of your nodes. Nodes means worker node, or up now the node, or you can say computer or server, have a different role function. So now Kubernetes say, hey, one of the our server known as a control plane, and all others considered as a node or worker node, you can say. And so why this is the one is spatial control and all are the normal node, because as mentioned control. So this is the node which are responsible to controlling the my cluster. Cluster in one cluster can have a node 1, node 2, node 3, node 4 lots. Right? And good options here, this is provide all the feature of whatever they discuss: self-healing, scalability, orchestrations, right? Now everything taken care by your control panel. So notice control plane is managed by your cloud provider using the whatever the API, but they have internally lots of server. This is one Kube API server, and ETCL, then scheduler, then control manager. The control manager manages everything. So generally, whenever a particular cloud providers are provide API, they are directly communicating via the control panel. So control panels, control planes know about everything. What are the my nodes one, node two, node three? What are the status, healthy or something? Okay. So little bit notice here some terminology like here uh, some processor running kube proxy, kubelet, and these are the pods. And these are the pods. Okay. So notice in one node can have a multiple pod. Pod is also and the particular pod our inside the particular pods or my container application run. Okay. So whatever my container application they are going to run inside the pod. A one pod can run multiple containers. Okay, so let's talk about detail pod as well as, and this is the node. What is the node? And the overall, this is the container containerized architectures for the Kubernetes. So Kubernetes work on the clusters of machine, and one machine known as a control plane, and all other machine known as just simple node or worker node. And control plane is responsible to managing, deploying everything by this here. So as the pod, okay. So pod is the basic execution unit in the Kubernetes. So finally, in the Kubernetes have a clusters, and this cluster have a couple of our nodes, and this one known as your control plane, and other node as a node one, node two. Inside node, the smallest unit is the pod. The pod is the just smallest R execution unit in the Kubernetes, and pod is logically host for one or more container. So notice inside one pod, you can generally we can deploy one container applications, or possibly you can deploy multiple container application as well as your pod is capable. And the support are the ephemeral and can be created, scaled, and deleted as needed. So pod is the smallest execution unit. Kubernetes can add more, can delete, can restart, everything can be do. Okay, and each pod have its own private IP address and communicated with other pods by the same cluster. In this cluster, this is one cluster. In this cluster, these ports are communicated to each other with the IP address. That means each pod have a own private IP address. Okay, so all the communication between your pods are happen via the, you can say, cluster IP or just private IP. So think as a pod is a logical host that contain one or more of containers. The container in a pod share the same resources like a network communication in each other. So overall, you can say in such a way, whatever the container applications which you are going to run, that your first your container, whatever the container package application, they run inside a pod. Okay, a pod can inside your actual node. Node means your machine. Node your machine. Okay, so here container can be many in a pod. Similarly, pod can be multiple pod in a node. So one you have a one node in node can have a multiple pod, and each pod can have a multiple container. The container is your application packaged form that have a your application library dependency. So let's discuss as a node. Which is a node is just like a worker machine in the Kubernetes cluster and run the nodes. Okay, nodes can be virtual machine or any physical machine. So here servers are a node, You can say, or you can say sometime worker node, just the machine. Machine can be virtual machine or your physical machine. And what machine do? They can say, I run multiple pods here, multiple pods here. Each pod can run the multiple container. What is the container? Container is your software application with its dependency, with its library and environment. And good part, each node in the container run pods, and the nodes is responsible to providing the necessary resources as CPU, memory. And so whenever you're running application, your application required, let's say your A application running. So surely your application required your CPU, required a memory, required a storage. So who will provide? So container, whatever the container your application have, they don't have. But under the pod which they are running, under the pod, this pod is responsible to the providing the CPU. So here pod is a logical unit. So finally pod run inside your node. Node means actual machine. Now actual machine have your CPU, memory, resources. So node provides us to the pod. Hey pod, you need a CPU, you need a memory, you need a resources. So they are provided. So worker machine, just think as a node, as a worker machine run on the pod. Node can be added or removed from the cluster. So in the cluster, multiple node can be node 1, node 2, node 3. You can add more node or you can delete nodes. This is also can be balanced automatically depend upon your requirements. Okay. Okay. So let's talk about the overall the Kubernetes architectures. We what happened? Yeah. So we discuss these are the major component in the Kubernetes architectures. One is the master node, or you can say control plane, the and worker node. You can say node, and these are some your basic component inside your control plane, like etc, API server, controller manager, and scheduler. Everything under your master or control plane node. And worker node responsible to run and provide the resources to the cluster. And master node is a central node or manage the cluster, including the API server, control manager, and everything. So you can say, as a high level architecture review, control plane is responsible to managing your clusters, and our worker node are responsible to allow run the pods, and pod required some resources they offer. And these are the internal about control plane a master node. They maintain the distributed key value store for the cluster state, clustering, running state, waiting state, pending state. All other states they can manage in the etc direct distributed key value store. And API server is the entry point for all the requests. If we developer are going through UI or CLI, the API servers are communication between the developer how to deploy application, scale application, right now. And control manager is the run and manage control loops, ensure the cluster states are desired state. So whatever the configuration file you tell, hey, the number of node would be, the pod would be, they are going to manage every nodes. If any pods are running, are unhealthy, are failure, they can find out, hey, these no pods are not properly running, maybe fail, can restart. Everything are managed by your control manager. And schedulers, schedule pods on the worker node and based on the resource availability and constraints. Okay. So these are the, you can say, all are the basic components, and we should be discussed already. Like pod is the basic execution unit in the Kubernetes that can compromise one or more containers. Containers your application with is library dependency environment variable, whatever they needed, right? And replica set, that means ensuring that the specified number of replicas of a nodes are running at a given time. So one what number of pod we want, that is specified a replica set. So deployment manage the rollout of your new version of application. Finally, whenever you are going to deploy any application or containers or application, you can say you want to deploy any application. So as we have to going to create the deployment. Deployment contain all the details which you want to deploy. Once deployment done, then we have to need the service. Provide the network identity and load balancing to accessing the group of nodes. So let us, our cluster can create the group of nodes and group of nodes. Question is how client, a customer or a client application can access my the clusters or which node we are finally our application deployed on as a container in the pod 1 or pod 2 or pod 3. Here a group of pods, collections of pods. So our client applications, how know which pod I am going to access. So for that, we need a concept of a service. So here Kubernetes provides, I am exposing this complete deployment as a one service. And this is the particular a public load balancer IP. So client are going to access my application with the public load balancer, and our this service know internally, hey, this is my deployment, and these all are the port. What are the IP? They are completely hidden from pod details. Pod IP are completely hidden from the client. Client only know, hey, this is my public load balancer IP. I am going to connect. The service is help us to provide networking. That means a public IP address in the form of load balancing, so that they can access your applications. And also we have a persistence. I want to some kind of a storage for the pod. We have there are two kind of a configuration also. One is a, instead of configuring hard code or something in your configuration YAML file, you have a, some config map where the key value you can just make one map and put some key and put some value. This value you can access anywhere in the configuration file, and these files are generally text format. And if you want to know, this is the secret. So another similar kind of things as a is secret. The secret allow us to store in key value format, but that are the not a human readable, not a plain text. Okay. So these are the basic about your Kubernetes. And now let's talk about the GKE, Google Kubernetes Engine Service Architectures. So if you talk here, almost the architecture, because the GKE cluster is built on the top of itself, like a Kubernetes. The same concept here, like again your control planes and your nodes, node 1, 2, 3. So again, whatever the user going to the connect from the kubectl is provided by the client library for, and now this communicate to the API server. API server have a resource controller, scheduler, storage, and now finally they are going to the controller, one more controller going to the manager nodes, and nodes finally have a deploy the multiple containers your applications here, and multiple node can be. Okay, so all the things are now managed by your Google Kubernetes engine, and this is known as a GKE managed services. So completely all the things from you are now taken care by your Google. You everything is now managed by the Google. Okay, even whatever the networking behind the concept, everything is taken care by the Google container. Kubernetes engine. Okay, and notice the Google Kubernetes engines provide these services in the two form. Okay, or you can say mode of operations in talk. So there are two mode of operations for the GKE cluster. One is the autopilot mode and another is the standard mode. So Google recommend you can use the autopilot mode because here GKE manage underlying the infrastructure such as node configuration, auto scaling, auto upgrade, baseline security configuration, and baseline networking configuration. So you can say now autopilot mode of GKE, everything is managed by Kubernetes, Google itself services. But some applications, somewhere you want know, I have a some specific hardware, a specific machine, a specific number of requirement I have. Then Google say, oh, let's. You have another option, standard mode. If you want, you can also manage everything, whatever the Kubernetes configurations, so physical networking, everything you can also can. So GKE support both autopilot mode and standard mode. So let's look basics. Okay. So these are the basics about the autopilot mode or standard pilot mode. Okay. So here notice they are fully managed again, and this is the GKE manage. So both notice both standard mode or autopilot mode, both are the Google Kubernetes engine managed services. But here full control, everything is managed by the Google Cloud, like your automatic upgrade, automatic repair, health check, automatic node scaling, automatic node creation and deletion, resizing your clusters, and leveling of your workload separation. So everything, whatever the Kubernetes functionality, just tell them Google everything. But in the case of a standard mode, something you as your application requirement you can also manage. Like here, say, hey, that is automatic upgrade, automatic repair, health check. That is the managed by Google itself. But no node automatic scaling or manual versioning upgrade, yeah, configurations, leveling, resizing, node pool creation, deletion, something control given to the user. Now your application, if needed, you can also do the configuration. Okay, so these are the two modes, and but recommended by the Google. Hey, use the autopilot mode. Okay, and this mode, whenever you are going to use, please be considered about the pricing model, right? So notice here, this is the recommended way, but what the pricing model? How will pay? Say you only pay for the compute resources that's your workload use while running. So whenever your application run and what the compute resources they are using, you have to pay only those resources. You don't pay for unused resources on the node, OS running, schedule workload, and system workload. No. But in the case of standard mode, you pay for the compute resources on each node, regardless of whether the pods running on the node or not. Pay unused resources. You should manage workload, scheduling, and minimizing resources. So you can say here, in the case of auto mode, you only pay when your application going to run. That means your requests come and your application consuming the compute resources. But in the case of a standard mode, whatever the cluster you decided, maybe your pod running, requests come or not, still you have to pay. Okay, so these are the pricing model we should always. I say, whenever you are thinking you are deploying your application in the cloud, always be consider the pricing model. You should aware, you should be clear how much I have to pay for which resources for the business, right? Because finally we have to pay first cloud provider. So let's do quick demo about how Google recommended autopilots or standard mode we can consider. Okay, so these are your GKE clusters. Okay, and in this GKE cluster you can go and all the products we have. So in this management compute, you have a networking and the serverless database architectures tools. There is the cluster management. Yes. So in the compute resources, there is a compute engine resources. So if you can go from here or just go from here and go to the compute engine. So this is the your compute engine. So in this compute engine, we have a clusters, workload, and everything's here. So let's go to the cluster. So now here Kubernetes clusters, and you can create, you can deploy, and so everything you can do. So let's try to create one clusters, Kubernetes cluster. If you create here, now you have a both option available. So if you notice here, so this is the by default they create in a autopilot mode. Okay, by default they create in a autopilot mode. But you want to go to the standard mode, then we have here another options like a switch to standard. So whenever you're going to create, click on the create cluster, these two options you have create autopilot mode. This is the recommended way, and if you want to switch the standard mode, you can also switch. But the cluster basics here mentioned. So that means we create autopilot cluster by specifying the name and region. And after the cluster is created, you can deploy workload through the Kubernetes or will take care of the rest including. So you can say in the case of autopilot, automatically nodes are created, networking settings are required, security parameter and other like telemetry like your logging, tracing, monitoring, everything is by default provided. So here in the case of autopilot, you just we have to tell, hey, this is my cluster name and which region I want to run, just, and everything now taken care by your application. Okay, so let's you want to go to the here like cluster. So this is the we are going to create this, but let's look for the switch to the cluster mode. So notice whenever you're switching the cluster mode and just say, hey, switch to the cluster mode, in the your standard mode. Now again we have options here. You are creating the standard mode, and standard modes you have to specify everything, your cluster basic information, like you have to specify your cluster name, your zone, regions, and whatever the regions. And here is the your node pool. So here you can specify, hey, this is my node configuration. I want like which kind of machine, like your general purpose machine, your compute optimized machine, your memory optimized machines, and different kind of series available. You have to select, and even you can say preset machine or custom defined machine. You can select them, And whatever the node detail, everything you can configure and consider. Even the networking, hey, you want to different BPC, different sub network, and whatever the detail you want, here you can specify your networking detail as well as. And what the other security parameter or any metadata, and maybe on the startup of every node, you want to uh, start some script, deploy some packages, deploy some dependency, everything you can consider here in the metadata parts. So you can configure yourself as your node pool, and even you can go your like automation, networking, security, backup plan, metadata feature, and your node pool. These all the things now a customer or you have an option to configure. But be carefully, whatever the machine, whatever the node you are selecting, you have to check your pricing model, how much cost you have to pay. Okay. So if you want, you can create your standard mode cluster. Yes, they have a full-fledged control of your application, and you can do everything whatever you want, right? Okay, so let's move to the switch to the autopilot. Yes, and let's just create some because note while creating cluster it will take times, and good option just go with the autopilot mode, but that depend upon your requirement, your need. You want to full control of your nodes, pods, and you want to manage yourself everything, so you can go with the standard. Else for the demo I am going to the for autopilot, so it can quickly create. And one thing, whenever you're going to create uh, cluster, it will take some time. So simply I go, hey, I put the name whatever you want to name, uh, whatever you want to name my first GKE cluster. Okay, just clusters, and you can provide your region, whatever region you want, and just create. Just minimum thing you have to provide, and now your complete clusters is ready. Just click create. Now your cluster is going to create. Now everything is automatically managed by your uh here. So whenever they are going to the create this cluster, it will take you can say 5 to 6 minute time, and whatever the things you are going to just wait. We cannot do anything until the cluster is not. So once your cluster is created, it will take time, and after that you are going to the deploy your application. So for deploying your application, or you can manually use the Kubernetes commands to create the deployment, create the service, create everything, or you can just wait. By default, this Google Kubernetes Engine console offer you to deploy application. So it will taking the time to just couple of things. Notice here. Thing first, they are whatever the configuration required for the autopilot mode they are doing, and after that they are going to deploying your application. Once deployment done, they are going to apply health checks everything, and once this done, then these all the informations here, cluster basics, whatever the default zone they selected, location types, and all other details about the upgrade part, automation part, your control plane networking, what are the public IP address, private IP address, and every informations here they are going to create. Okay, so let's wait until this is not completed, and once this is completed, what we're going to do, we are going to do apply the deployment, and once deployment done, we can just test any applications. You can go and deploy any applications, containers application. You can just say, hey, this is my container path, and this application I'm going to deploy it. Okay. So this till now, let's go to the our uh, hmm. So if you want to deploy yourself manually, that's we are doing here automatic, but you can do yourself in the case of standard mode. How you make a deployment and how you make a service available from the G Cloud commands. Okay, so good option. Just once your deployment happen, cluster is created. Once your cluster is created, this is the cluster created, and cluster automatic. We have a your control planes and a set of your nodes already created. So here you now your responsibility, you have to deploy your application. So first we have to create here the first step, we have to create deployment. So create deployment and just give the deployment name and images. Here you tell your the complete container image path. Okay, from the Docker Hub, yeah, cloud, Google Cloud API registry, and this is the this Docker image contain everything about your package setting, everything whatever needs, and just say, hey, this will create your deployment. So now, if you check the deployment, get deployment, you can get deployments and get pods, get the detail, the what number of pods they are created for you. But now these applications, whatever the application you are going to run under, as a container inside a pod. Okay, so this is your container application. They are going to run inside the pod inside a node. Node is a part of a cluster. Okay, and but how client is going to access this application? Okay, so then we have to expose services. So it says, hey, kubectl expose and say, hey, this is my deployment. This is my deployment. This is the deployment name, and I want to load balancer types of deployment. And here specify your port 808. Now customer say, hey, this is the 808 port, and this they expose one public IP. This is the public IP and the particular port. Now customer can go access your application via this public IP and this. And if you want to get the service detail, just get service complete detail, and everything you want. Hey, I want to delete the complete clouds, just kubectl delete all, they can delete the cluster. So these are things you as a engineer do manually in the case of Kubernetes standard mode. Okay, so let's our deployment still deployment done, health checking going on, let's wait. So this is the one part, and let's sometime you want scaling. You want to scale your application. Yeah, scale your deployment and a cluster. Scale means you are going to add more. So let's say this is simple manually. Go to the kubectl scale deployment, your deployment name and replicas. Here you say replica set is equal to 2. So they are going to create a 2 deployment for you, a 2 pod where the deployment running. Okay, maybe 3, maybe 4, whatever you want. That is, this is the manual scaling. So in the case of standard, you have option, you can do manual scaling as well as auto scaling. So this is the scaling of your deployment. Deployment means the number of nodes or pods running. Okay, so here sometime you want to uh, increase your nodes. So they are increasing the number of pods, pod 1, pod 2, pod 3, but pod run inside the nodes. How you can add more nodes? Or you can say means increase the cluster. So you can use the G Cloud container cluster, resize your cluster name and the node pool, just default pool. What is the number of node you want and the zone, which zone this cluster is running. So you have an option. If you want to scale your clusters, then you can use the G Cloud container command. If you want to scale your pods, then you can use the scale deployment. So finally, our still cluster going to create it. Let's talk one more things about the auto scaling. Let's say you want to automatic scaling of your deployment in cluster. So instead of just scale, hey, kubectl auto scale deployment this. and just tell this is the maximum number of pods could be. And so question is how auto scaling happen, on which criteria the parameter clusters is going to add more port for you. So you have to say, hey, if CPU percentage is 70%, 80%, or any different criteria you can specify, on which, what is the algorithm scheduling, the strategy on which basis scaling going to happen. Okay, and just create let's say a CPU percentage. In this ways, your applications, any ports going to the mode CPU percentage and 70%, automatically your deployment going to scale and scale down accordingly. Similarly, you want to auto scale for your clusters. So instead of resize, just say, hey, update. You can say gcloud container cluster update, your package name, and enable auto scaling. And whatever the minimum number of node, whatever the maximum number of node, you can just specify. And now your application or cluster also become automatically scale. You don't need to tell them. Okay. So automatically scaling and automatically deployment possible in the case of standard mode as well as. So hope, yes, my deployment is done. Okay, so notice now your cluster is ready. Cluster is created, okay? And let's go to check our cluster. And this is the complete cluster basics. All the, notice the, there are two mode, but this is the mode, our autopilot mode, okay? And these are our default zones, and these everything's here, everything good. And our networking detail, and your metadata, if something features, what are the features by default, these are the logging features. By default, cloud monitoring, these are features already available, and lots of other things enable, some enable, some disable, you can enable it. So question, let's keep now our clusters is ready. Notice my clusters is ready. Clusters means they have a one control plane and some set of nodes. Okay, but here no application. Now how I can deploy my applications on the pod, multiple pod inside the node. So one things, as we discussed, we can create a go deploy manually using the gcloud command, whatever the command we discuss. But we are in the standard mode, so everything is also open from the here. So notice here we have option deploy. Click in deploy. So whenever you are clicking deploy, that means you have to tell, hey, I am going to deploy my application. Whatever deployment name you want, what is the default space, and everything you can mention here. Okay, and say, hey, I am going to deploy. Okay, deployed configuration, and just click the deploy. So in this way, our deployment automatically going to the create. And everything you can create deployment manually from command line, which I can share. You can specify the, they can also create a service for deployment and service in everything. Sometime always because cluster activities take times to deployment, but yes, deployment happen. And everything you can do from the manually command line as well as, right? And as we discuss, we can also configure. some config map. kubectl command have options to config map, create a configuration map like your database name, and this is the key and this is the value. But these are the plain text. You want to not a plain text but the different secret non cipher text, then you can simply say, hey, create kubectl create secret, and tell your this is my key and this is my value. So multiple config map or secret you can create in your application, right? So good part, whatever the things we discuss, everything you can find in the resources available. Okay. So finally, our deployment created. Go to the cluster, go to the work node. This is the workload. This is the one deployment first, and this deployment. Okay. This is the deployment. The digital deployment detail you can check. Like here comes the deployment detail, and by default which application they're running, they are the default container they're running, and whatever the here you can specify the container, whatever the container detail while the clicking. And this is the complete by default ports. These are the three ports running, and if you want to expose, you can just expose, and you can say, hey, this is the my port and this is the my service. First we create deployment, just like here I can say, first you have to create the deployment, then we have to expose services. So these all are the offer by default inside your here. First we create a deployment. Now okay, hey, port 808 this run. If you want to add any mapping, just say, hey, no, create your a service. Now first deployment created, that means we have selected, hey, this is the my image, like we have a default nginx server, any other server you can specify. And once deployment done, you are going to create services. That means what services do, they are going to use a load balancer and for external ip. This ip is used for client your application to access these clusters. It will take little bit time to just expose services. Now it's done. So now our clusters, first we created the cluster. This is the we created my cluster. In this cluster, we deployed our applications in the workload. We deployed our applications and the form of containerized application. And in this containerized application, we expose services so that we are with the load balancer and public IP. So this is my application which are running, and these are my your active versions of applications, and these are my your managed ports. Here the three instances are running, and this is my exposed services. And notice this is the types of load balancer, and this is my public IP address. Whenever a client can access this public IP address, your applications are going to deploy. And now our application web server like nginx is running on your clusters of GKE. And any application whatever you want to deploy, just maybe new configuration, new version, by default revision 1, new version you want, you can change this pod specification, right? So these are the basics about, and all the details you can find more details here. Everything like your name, space, and what the labels details, your scaling, and what are the upgrade strategy. And notice here like replicas 1 maximum 5 CPU utilization out of 80%, and these are the configures and pod your application, and this is the container. Okay, this is the container you want. If you want to some change something, you go, and everything in the YAML file you can go, or you can just check all other parameters like overview and details, observability. That means by default, some services like CPU percentage, CPU overview, memory instruction, and all of the states of cubes states you can get here. And your which versions are generally we deployed. This is the version, multiple version you can deploy it here, and this is the event. You want to check the logs, okay? So these are the logs file. Go and checks whatever the log level you want, like info, debug, and whatever the things going on. This clusters is loading. Okay, this will just load. And whatever the things as you mentioned, they can support via Kubernetes support via configuration file. If you want, you can simply go, this is the my configuration file, and all the configuration file contain, hey, this is the deployment, and this is the my your everything details, deployment name, application, and what are the details in this you can specify in file. Okay, this is the my minimum replica set, maximum replica set, everything's here mentioned. So these are the basics about your clusters. And here in the UI clusters, you can find your cluster itself here. This is the standard mode. And whatever the deployment you're going to create, in the workloads, this is the new deployment you can find in the deployment one. And deployment one under your service deploy. The multiple deployment you can do here. Next question, let's how I can go to the connect this deployment. Maybe I want to run manually command to get update, delete everything. So go to the clusters, and the clusters, open the clusters, and in the cluster you have option connect. Just go, and this is the command. They say, hey, G cloud container collect, get credential, container name and region. Just copy this command, and just go to the console. Go to the console, and just run here. Okay, so you are now you can just run this command. You are inside the cluster, and whatever the command here you want to run, like any cube ctl get pods. Okay, so you can run this command. Whatever the Kubernetes command you want to run, here you can run. This is the like detail white. So where this our this is the complete deployment. I want to get deployment. Everything you can check here. Get, so all the Kubernetes commands you can get. Get deployments, and this is the one deployment. Get service. Okay. So these are the services running, and these are our public load balance a public IP for which port is. So everything, whatever the command you want to, just go to the connect here on your cluster, and even you can create the cluster from the auto pilot mode or standard mode. Both we have the option to connect, and whatever the sometime you want to check the from command lines, and everything you can consider from here. Okay, so these are the basic overview about your GKE cluster. And one thing, whatever we did, you can just create cluster from any mode. Maybe to recommend this way, autopilot mode. And if you are going to create the standard mode, you can choose your machine, everything, and once done, then connect your cluster and create the deployment. And deployment, you can just specify your containers URL, and after that expose as services, so that you can specify the port, load type balancer, so that your client can get the public IP address, because each port have some cluster IP, that's a private IP that can internal communication happen. Okay, and if you want to delete everything, you can command on the delete commands. Okay, and similarly, you want to manually scaling, just scale the kubectl scale deployment and set the replica. If you want to scale your cluster, just resize your clusters. Similarly, you want to auto scaling, you can say, hey, kubectl auto scale your deployment name, maximum, and the criteria. Similarly, cluster, just update the cluster and said, hey, enable auto scaling, and this is the minimum node, this is the maximum node, automatic scale happen in clusters. And similarly, you want to create the config map, you can create config map, you can create a secret, just say, hey, kubectl config map, this is the key, and this is the key and value, this is the key and value. Okay, this is the help of dynamic, instead of manually writing username and password inside your configuration file, that help us to use then the secret or config map. Okay, and all other documentation you can find about the GKE, whatever I discuss, everything you can find here in this GKE overview, each din architecture overview, whatever. This is the official document, and good option, you can go and read out whatever we discuss. Everything you can find here, the platform, what the autopilot mode, what the release, what the improvement, custom optimization, and even the reliability and availability, 99% SLO signed by the Google Cloud. You can just go through this documentation about the. And if you want to learn basic about the Kubernetes, this is the official documentation about the Kubernetes. Just go to the clear, what is the overview, what is the architecture, container, workload, what is the services, load balancing, networking, storage, configuration, config map, everything you can find here. Just read out if you want to, because whenever we are going to work, we have to need the basic understanding. A basic understanding only you can get if you visit this documentation and read yourself. Okay, just this is my intention is that whatever I read, so that you have get little bit overview. My objective just give the overview, so that now you think maybe you want to learn more details, read out this documentation. Okay, so what did today we cover? Right now, simple GKE cluster. This is the fully managed Google Cloud Platform services, and here say you can deploy your application on the clusters. Cluster means a group of your nodes, group of your a group of node 1, node 2, node 3, multiple nodes can be, and your one control plane that's manage the every deployment, and your application can deploy inside the pod, and multiple pod can be a particular node, and inside the pod your container application going to deploy it. Okay, and and once you create the deployment for the pod, you create the deployment, and how customer can access the deployment using the public IP address, that is exposed by the services, exposed services, and by the load balancer. So everything load your application scaling, auto health check, auto scaling, and all other your application deployment, application upgrade, any kind of update, everything. Even the GKE say zero downtime. If your application running, still you want to make a new version of your application, you can do everything. So that's a very nice feature about the Google Cloud as a GKE service that help us to deploy my containerized application on the clusters. And our Google Cloud itself manage your cluster, your scaling, your health check, your scalability, availability, durability, everything taken care by the Google. So hope this information is helpful for you. Thank you.